Let's knock out this review sheet. Review Unit 6. Make sure that you find the right title. Some of you have struggled finding the right one. Make sure that you find the right one. This one should be easy. It has Miss Newell's handwriting on it. We're going to let set A be the kids who own an Xbox. Let set B be the kids who own a PlayStation. Find A intersect B, or A and B. This would be the people who own an Xbox and a PlayStation. Looking at this Venn diagram. Who owns an Xbox and a PlayStation? Sleepy and Sneezy. They own an Xbox and a PlayStation. A or B, A union B. These would be the people who own an Xbox or a PlayStation. Does Doc own an Xbox or a PlayStation? Yeah, he's got an Xbox. Does Sleepy own an Xbox or a PlayStation? Yeah, got both of them. Bashful, Xbox or PlayStation? Yeah, I got a PlayStation. Dopey, you got an Xbox or a PlayStation? No, I go outside and play other things like normal people. Okay, cool. You won't be on the list. This will be Doc, Grumpy, Happy, Sleepy, Sneezy, and Bashful. Okay. Find A, the complement of A, or A not. Those who do not own an Xbox. Who doesn't own an Xbox? Well, does Doc have an Xbox? Yup. Does Sleepy have an Xbox? Yup. Does Bashful have an Xbox? Nope. Dopey? Nope. So Bashful and Dopey don't have an Xbox. Okay. The set A intersect B represents, that's and. So people who own an Xbox and a PlayStation, that would be D. A or B, people who own an Xbox or a PlayStation. I think that's choice A right there. And then over here, if your totals aren't given to you, you need to find all your totals, okay? So add these together, you get 1160. Add these together, you get 1592, 148. Add across 1506 and 1394. What is the probability that a randomly selected person has blonde hair given that the person selected is male? That means that I need to circle the males here. Given that the person selected is males. I'm only looking at the males. How many of those males have blonde hair? 876. You can leave it like that. That's fine. I know it will reduce. That's fine. Given that the person has red hair. I'm only looking at the people with red hair. How many of those people are females? 66. I know it'll reduce. You can reduce it if you want to. All right, we've got which of the following events are independent. This has got you on several of your graded assignments. You just went down to the last one's like, oh, those are the same numbers. I threw an extra decimal place, and I don't think that it was D was the correct answer. So make sure that you multiply these out, and you get that last one. 0.25 times 0.25 is not 0.5. 0.08 times 0.4 is not 0.12. The last one in this case is, you would say 0.3 times 0.15. That would be 0.045. Some of you even wrote it out 0.03 times 0.15, and it was wrong, even though you said it was equal. But on this one, it is. Make sure that you multiply them out, make sure you get the right answer. In a certain school, the probability that a student plays a sport is 30%. I would write that as 0.30. You could write it 0.3 is fine. The probability that a student is a senior is 20%, 0.20. The probability that a student plays a sport and is a senior is 6%. That would be 0.06. Are the events independent? Well, I have this thing, probability of A and B equals probability of A times probability of B. So I'm going to plug it in and see if that holds to be true. And if it does, they're independent. If not, then no. So I got that and is over here, 0.06. And then the two individual ones, 0.3 times 0.2. 0.3 times 0.2 is 0.06. Yes, independent. Okay. Number 10, in a particular state, the first character on a license plate is always a letter. The last character is always a digit, 0 to 9. If V represents the set of all license plates beginning with a vowel, what are vowels? A, E, I, O, U. And then some of you said, and then sometimes Y. Ha, I caught you because I knew you were going to say it. Yeah, sure, sometimes Y. We can have that discussion at a later date. If you don't know that, then you can watch reruns of Wheel of Fortune, probably on Netflix or something, I don't know. And they have to buy a vowel. So sit down, watch Wheel of Fortune with your parents or something. V represents all vowels. And O represents the set of all license plates that end with an odd number. Okay, so O means it ends with an odd number. Which license plate belongs to V intersect, so that's and, O not? So V and O not. This means it starts with a vowel and it ends with something that is not an odd number. What would not an odd number be? An even number. So I need for it to start with a vowel and end with an even number. Start with a vowel, end with it. Man, that was quick. Is it A? Start with a vowel, end with even. Vowel, not even. I think it's called a consonant. Consonant, if it's not a vowel. So just be aware of that. If it's not a vowel, there may be on a graded assignment moving forward. Let's look at the back. All right. Assume that the following events are independent. Well, if it's telling me to assume that they are independent, that means that this thing holds true. Okay, I would normally point to your blue sheet. I'd point up on my wall and say something how it's not a blue sheet, it's a white sheet, but look up on the wall. If it's independent, then this holds true. We just did that on the 2 problems ago. The probability that a high school senior will go to college is 0.72. Okay, that's one thing. The probability that a high school senior will go to college and live on campus is 0.46. What is the probability that a high school senior will live on campus, given that the person will go to college? The and right here, 0.46. One of those things, 0.72. I need to figure out what the other one is. I'm going to solve for x. I'm going to divide. So x would equal 0.46 divided by 0.72 on both sides. And you would get 0.63888888. So that would be D, I believe. All right. Use the following chart on 12 and 13. What is the probability that a card is a heart, given that the card is a face card? All right, given that the card is a face card. I'm only going to look at these, given that it's a face card. So 12. What's the probability that it is a heart? 3 out of 12. You could reduce that to 1/4 if you want, but I know your calculator, it is what it is. 13. Given that the card is not a face card, so not a face card, 40. What's the probability that it's a heart? 10 out of 40? That would be 1/4 as well. In The Walking Dead, there are 8 men and 6 women in a group. At this point in their lives, 3 men and 2 women have killed a walker. A walker would be like a zombie, for those of you that are normal and don't watch that kind of stuff. If a person is chosen at random from the group, what is the probability of choosing a man? The probability of choosing a man would be 8 out of, I think there's 14 total people there. Or, means add. A person who has killed a walker. How many people have killed a walker? 5 out of 14 have killed a walker. Is there any overlap there? Are there men who have killed a walker? Yeah, 3. That would be 10 out of 14. 8 plus 5 minus 3. Bring your denominator over. Okay, you can reduce that. Number 15, if a person is chosen at random from the group, what is the probability of choosing a woman? How many women we got? 6 out of 14. Or add. A person who has not killed a walker. Well, if 5 people have, 5 out of the 14, have killed a walker. That means that 9 out of the 14 have not, but there are women who have not killed a walker. How many women have not killed a walker? Well, 2 have. That means that 4 have not. I believe that's 11 out of 14. All right, Joe has a number cube. I feel like I've done 10 of these. You can check out the other video for those two. Big thing to notice, this one says, given that at least one of the rolls is a 4, you would only write all the ways you could roll a 4. Okay, so 1, 4, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, all those. Over here, keyword is or. So you'd write all the ways you could get a prime number. Or means add. At least one of the rolls is a 3. Roll 3, 1, 3, 2, 3, 3, 3, 4, all those. Add them up, subtract any overlap. Let's look up here. Bill spins 2 spinners that have 4 equal sections, numbered 1 through 4. If he spins a 4 on at least one spin, that's like saying, given that he spun a 4 on at least one of the spins. Okay, so it's got 4 equal sections. We know that one of them is going to be a 4. 4, 1, 4, 2, 4, 3, and 4, 4. Why did I stop at 4? Why didn't I go to 6? We've been going to 6 lately. There's only 4 sections on the spinner. We've been going to 6 because we've been rolling number cubes and there's 6 sides to the number cube. So if he spins a 4 on at least one of the spins, what is the probability that the sum of his 2 spins is an odd number? Okay, we have 7 total there. The sum is an odd number. Those would equal 5, those would equal 6, those would equal 7, that would be 8. So 5 and 7 are odd numbers. That's 1, 2, 3, 4 out of 7. Each letter of the alphabet is written on a card using a red ink pen and placed in a container. Each letter of the alphabet is also written on a card using a black ink pen and placed in the same container. So we've got, every letter of the alphabet. So 26 written in red, thrown in a container. And then we've got 26 cards written in black, thrown into the same container. So we got a total of, 52 cards in the container? A single card is drawn at random from the container. What is the probability that the card has a letter in red? Is the letter R or the letter G? Or means to add. So what is the probability that the card has a letter written in red? Well, how many cards are written in red? 26 out of 52. Or the letter R. How many lettered R's we got? Well, we got one that's red, one that's black. But there's some overlap there. We put 2 R's here. One of them's red. We already counted it over here. Okay, minus that one red R. And then, or the letter G. How many G's we got in our container? 2 of them. One of them's red, one of them's black. But we already counted the red one over here. 28 out of 52. That will reduce. Not too worried about it. Slide up. All right. Remember on these, we got to write these out. Even numbers in the interval 6 to 10. This would be 6, 8, and 10. Find A union B. That means A or B. Is the number found in A or B? Well, let's write everything that's in A or B. 2, 3, 4, 5, 6, and 7. Those are all the ones found in A. Or B, we've already written 6. We haven't written 8 or 10. Okay. Number 21. We need the stuff in B and C. Okay. 6 is in both of them. 8 is in both of them. 10. So all 6, 8, and 10. A intersects C. Okay, so we need the stuff that's in A and C. 5, 6, and 7 maybe? A bag contains 2 red balls and 6 green balls. You randomly draw 1 ball. Do not replace it. Dependent event. And randomly draw a second ball. What is the probability that the first ball is red and the second ball is red? All right. So we have, 8 total? What's the probability the first ball is red? 2. And We did not replace it, so now there's only 7. The second ball is red, so we took 1 red ball out. How many red balls are in there? 1. It's 2 out of 56. You could reduce that to 1 out of 28. Number 24. You write each of the letters of the word Kansas on pieces of paper and place them in a bag. There are 1, 2, 3, 4, 5, 6 letters in Kansas. You randomly draw 1 letter, replace it, independent events. Then randomly draw a second letter. What is the probability that the first letter drawn is an S? We've got 2 out of 6 are S's. We replaced it, so there's still 6 in there. How many N's are there? 1. 2 out of 36. That will reduce to 1 out of 18. Not too worried about it. Number 25. A code consists of 2 different digits. Different digits, followed by a letter of the alphabet. What's the probability that the code is 83X? Well, we got 1 out of 10. And then since they're different digits, the next one would be 1 out of 9. And then letter of the alphabet would be 1 out of 26. We're going to multiply those things and get 1 out of 10 times 9 times 26 is 2340.